Give it up. So take a look at this first one, the first question from it. It is May June 2021 exam, and this is paper 2, variant 2. Take a look at the first question. It states group 2 metal combines with bromine to form a crystalline solid MbR2. Excess aqueous silver nitrate is added to a solution of MbR2 and a precipitate forms. The mixture is filtered, the precipitate is dried, and the mass of the precipitate is recorded. State the formula and color of the precipitate. Now we know that in order to identify the type of halogen atom,
कलर तो क्रीम है ना, क्योंकि वो ब्रोमीन में जब
yes,
सिल्वर नाइट्रेट जाता है तो वो तो क्रीम.
So the silver ion actually reacts with the bromide ion from MbR2, and the precipitate formed, that is silver bromide, and you know it's a cream colored precipitate. Part B, complete the equation to represent the reaction between MbR2 and silver nitrate. Now we know that one of the product is the cream colored precipitate, which is silver bromide, and then a group 2
MnO3 और ब्रैकेट 2 लगा.
एक group 2 metal nitrate बनेगा. We know group 2 के जो elements हैं, it has an oxidation state of +2 or valency of 2+. Therefore, the formula for this nitrate, that should become what? MnO3 whole 2. We also need to put 2 here and 2 here with silver nitrate in order to balance the chemical equation. So now the equation is balanced as well. The next question is a 0.25 gram sample of pure MbR2 contains 8.415 times 10 raised to the power minus 4 moles MbR2. Calculate the relative formula mass Mr. So Mr is the thing that needs to be calculated, and use this to identify M. We need to actually show our working as well. So we need to calculate the Mr, or the quantities given to us are the mass and the moles of MbR2. So इसी से ही हम calculate कर लेते हैं भाई.
Mole divided by mass.
Yes, we can do that using the formula, or we can do that using the ratio method. We usually prefer the ratio method in ASA2. So MbR2, its mass is being related with its moles. Now take a look at the data, which says that it's 8.415 times 10 raised to the power minus 4 moles of a mass of 0.25 gram. So if its moles are 1, then what will be its mass? You know, the mass of 1 mole of a substance is actually its relative formula mass expressed in grams. So let us calculate this value. X, this will turn out to be 0.25, which is the mass, divided by the moles, which is 8.415 times 10 raised to the power minus 4. So this will be the relative molecular mass of the compound. And if we calculate it, it turns out to be 297.1. You can round it off up to 297 as well. So what would be the mass of this metal M? Mass of metal M, ये कैसे calculate करना है?
Periodic table से देखेंगे क्या?
Yes, using the periodic table. You see the relative molecular mass, or how is that calculated? Mr of MbR2, you know that it's 297.1 or 297. Now how is it calculated? We multiply the mass of M, the AR of M, times 1, as we can see there is only one metal M atom here, plus the relative atomic mass of bromine times 2. And when we sum it up, it should turn out to be 297.1. So mass of M, that is unknown, and multiplied by 1, it should stay as X. The relative atomic mass of bromine from the periodic table is 79.9. And we have to multiply it with 2 as well. So this is equal to 297.1. So X जो है, that will turn out to be, yes, 297.1 minus 159.8. You have a calculator? Yes, son.
ये तो 297 minus 160 हो जाएगा ना?
हाँ, 160 या 159.8, because the relative atomic masses हम जो periodic table given होता है आपको वहाँ से देखते हैं, so we have to use those.
ये तो ये बेरियम हो गया.
So its mass turns out
137 आ गया बेरियम.
137. 0.4 आ रहा है या 0.3 आ रहा है इस वक्त, but we know that this metal M is actually worth barium. If you take a look at it at the periodic table, barium is the element from group 2 which has a relative atomic mass of 137. Okay, take a look at part D of the question. A sample of MbR2 is dissolved in water. Chlorine gas is then bubbled into the solution. Describe the observation for this reaction. Now you know that overall what is the reaction? Chlorine gas is bubbled through MbR2 aqueous solution. Now we know that chlorine is a more reactive halogen than bromine, so it can displace it, and it can displace the bromide ions from it. Thus, it should result in the formation of MCl2, which is a colorless aqueous solution again. And what should be produced? Bromine is produced as well. So what should be the observation for this reaction? Chlorine we know is a yellowish green gas. All the compounds of blue are white and their aqueous solutions are colorless. और यहाँ पर bromine produce हो रहा है in its aqueous solution. So what should be formed? We should say that the solution.
यही कह देंगे brown vapor हो गया.
Yes, the solution turns brown or orange. दोनों कलर्स जो है वो मार्किंग स्कीम में लिखे जाते हैं for it. Okay, name the type of reaction that occurs when MbR2 reacts with chlorine gas. We know it's called what? A displacement reaction, where a more reactive element replaces a less reactive element from its compound and takes its position. So this is called displacement reaction. Compound Y is a pure insoluble solid which contains halide ions. So it's a different compound that has been mentioned in this part of the question. They're telling that this is an insoluble solid, and this insoluble solid has halide ions in it. A single reagent is added directly to the compound Y to determine the halide ion present. Identify the reagent added, state the observation which would confirm that Y contains bromide ions.
तो अमोनिया डालेंगे.
Actually, जो reaction है, the reagent is the concentrated sulfuric acid. Which is written as H2SO4 liquid. This is the symbol for complete symbol for sulfuric acid, concentrated sulfuric acid. And if you can recall, actually sulfuric acid, when reacts with any compound that contains the bromide ions, like for example sodium bromide, what happens? In the first step, sodium hydrogen sulfate is produced, and with it HBr is also produced. In this first step, sulfuric acid actually behaves as an acid, because this reaction, the one that has been written here, is not a redox reaction. But right after this reaction, the reaction does not stop.
Oxidizing agent के तौर पे behave करता है.
Yes, it does not stop here. The reaction does not stop here. And what happens, since the hydrogen to bromine bond, HBr bond is weaker, so sulfuric acid can oxidize it as well. So sulfuric acid will further react with the HBr produced in this reaction. And then what should be found? Bromine is produced
The bromine plus sulfur dioxide plus water.
in the gaseous state. Yes, another acidic gas is also produced, which is sulfur dioxide. And along with that, water is also produced. So what would be the observation? The observation should be related with the color change that is associated with bromine. So one can easily say that the gaseous bromine यहाँ पे produce हो रही है. What will you see? Orange vapors.
अच्छा तो एक बात बताएं, जो हमने हैलाइड आयन का एक टेस्ट होता है, तो वो मैं ये समझ गया कि ये हम इस तरीके से कर सकते हैं, लेकिन क्या उससे नहीं हो सकता अगर हमने अमोनिया ऐड किया? मैं समझता हूँ कि उसमें वो डिफरेंट कंडीशंस भी होती हैं कि अगर हम जो है डाइल्यूट अमोनिया करें या कॉन्सेंट्रेटेड अमोनिया करें, लेकिन हमें उससे फिर भी कलर तो पता चल जाएगा ना, फिर ये तो कंफर्म हो जाएगा ना कि ब्रोमाइड आयन है.
Yes, उससे भी confirm हो जाता है, but they have already mentioned that reaction with silver nitrate, जिसमें color of the precipitate पता चलता है. In fact, आप जिस अमोनिया के टेस्ट की बात कर रहे हैं, that is whether this precipitate formed dissolves in dilute aqueous ammonia or concentrated aqueous ammonia. तो आपको पता है dilute के अंदर तो ब्रोमीन जो है वो dissolve ही नहीं होता, ठीक है. And concentrated के अंदर dissolve हो जाता है, but concentrated के अंदर तो क्लोराइड भी dissolve हो जाता है. Therefore वो ब्रोमाइड और क्लोराइड दोनों के लिए टेस्ट बन जाएगा. अच्छा, जो फर्स्ट अगर डाइल्यूट अमोनिया की अगर आप बात कर रहे हो, तो डाइल्यूट अमोनिया में ओनली द क्लोराइड आयंस आर सॉल्युबल, बट ब्रोमाइड और आयोडाइड दोनों इनसॉल्युबल रहते हैं. तो अगेन उसको भी फिर यूज नहीं किया जा सकता एज अ टेस्ट टू वेरीफाई ब्रोमाइड फ्रॉम आयोडाइड आयंस. सो देयरफॉर यहाँ पर सल्फ्यूरिक एसिड इज आल्सो बिहेविंग एज एन ऑक्सीडाइजिंग एजेंट. समटाइम्स दैट कैन,
ये वाला ज्यादा बेहतर है क्योंकि इससे डायरेक्ट हमें
यस, इसमें डायरेक्ट रिएक्टेंस मिल जाता है एंड देयर इज नो कंफ्यूजन.
लेकिन अगर बंदा वैसे अमोनिया का ट्राई करे तो गलत तो नहीं होगा ना, मतलब हो तो
उसमें आप
सकता है ना.
कंफर्म नहीं कर सकते, बिकॉज अगर आपने डाइल्यूट एक्वस अमोनिया यूज किया और वो प्रेसिपिटेट डिसॉल्व नहीं हुआ, तो दैट कैन बी आइदर ब्रोमाइड और आयोडाइड, ठीक है. और कॉन्सेंट्रेटेड एक्वस अमोनिया में क्लोराइड्स और ब्रोमाइड्स डिसॉल्व हो जाते हैं, तो देन अगेन यू कैन नॉट बी श्योर इफ इट्स अ क्लोराइड और ब्रोमाइड. देयरफॉर दिस इज द बेस्ट टेस्ट. Okay, take a look at part F. Separate 1 gram samples of 3 different magnesium salts are tested in order to identify the anion present in each sample. Explain how the action of heat is used to identify which sample is magnesium carbonate, magnesium nitrate, and magnesium oxide. Yes,
इन
sir.
तीनों की डिफरेंट डिकम्पोजिशन है. वो नाइट्रोजन डाइऑक्साइड देता है, वो कार्बन डाइऑक्साइड देता है, वो
Yes.
तो
We know that magnesium carbonate can be decomposed upon heating, and whenever a group 2 metal carbonate decomposes, what does it form? A white solid, which is magnesium oxide, and along with that we'll see a colorless, odorless gas, which is carbon dioxide gas. So we'll see the observation related to the carbon dioxide. Magnesium nitrate जो है, that is,
वो मेटल ऑक्साइड प्लस नाइट्रोजन डाइऑक्साइड प्लस ऑक्साइड.
yes, it should convert into metal oxide, nitrogen dioxide gas. What is the color of nitrogen dioxide gas?
ब्राउन होती है ऑक्साइड.
Yes, it's brown. And along with that, oxygen gas
Oxygen.
is also produced. We need to put 2 here and half here. Or magnesium oxide is a very stable.
बस मेटल प्लस ऑक्सीजन देगा.
नहीं बेटे, actually there is no reaction. No matter how much you heat magnesium oxide, It will not
अच्छा वापस रिवर्स नहीं हो सकता वो अगर हमने किया?
नहीं, वापस रिवर्स भी पॉसिबिलिटी नहीं है, क्योंकि इवन व्हेन मैग्नीशियम ऑक्साइड ब्रेक्स, क्या होगा भाई? In magnesium oxide, there are magnesium ions and oxide ions. Even the bond between them breaks. Still, it will be what? Gaseous magnesium ions and gaseous oxide ions. ठीक है?
अच्छा ठीक।
First of all, ये liquefy हो जाएंगे, liquid ions के अंदर convert हो जाएंगे, molten, and then अगर further heat provide कर देंगे, तो it will produce gaseous magnesium ions and gaseous oxide ions. But magnesium oxide will not be broken down into any simpler substance. So what do we need to write? Okay, the magnesium carbonate and magnesium nitrate will lose mass when heated. As you can see, different gases are evolved, so they will leave that apparatus, and thus the mass of the carbonate and the nitrate will decrease. Second thing is that uh, magnesium nitrate produces brown fumes of nitrogen dioxide gas. And what about magnesium oxide? Magnesium oxide shows no change upon heating. So melting point भी वैसे बहुत high होता है, it's above 2000 degrees Celsius. So obviously बाकी जो जिन temperatures के ऊपर carbonate and nitrates decompose होते हैं, उन पर अगर लेके जाएं तो there will be no change in it. Okay, now the next part is complete the electronic configuration of the magnesium cation present in these salts. So magnesium cation is magnesium 2 positive ion, and we know the proton number for magnesium is 12. So when it loses 2 electrons, there should be actually how many electrons in it? 10 electrons. And 10 electrons की electronic configuration कैसे लिखोगे भाई? 1s2, 2s2, and then 2p6. This is how 10 electrons can be accommodated in the subshells of magnesium cation, or the 2 positive charge magnesium atom. Part G. A sample of magnesium carbonate is distinguished from a sample of magnesium hydroxide by adding a small amount of each solid to HCl. State one similarity and one difference in these two reactions. Suppose in the beaker there is hydrochloric acid, and we are putting a piece of magnesium carbonate into it. So what will we see? We'll see bubbles of a colorless, odorless gas.
उसमें क्योंकि कार्बन डाइऑक्साइड प्रोड्यूस होएगा, सॉल्ट वाटर कार्बन डाइऑक्साइड, उसमें खाली सॉल्ट वाटर प्रोड्यूस होएगा.
Yes, उसमें सिर्फ salt produce हो रहा होता है and water भी produce हो रहा होता है. But what
ये कैसे थे सिमिलैरिटी में कि दोनों में एक कलर सॉल्यूशन है और डिफरेंस है बबल्स?
No, that would not be actually. देखें, मैग्नीशियम कार्बोनेट when it reacts तो दो observations होंगी. एक तो bubbles produce हो जाएंगे. What will happen to magnesium carbonate? This solid will react, और इस solid का mass decrease होता जाएगा. So the observer should say the magnesium carbonate, the solid dissolves in the acid ultimately. Similarly, magnesium hydroxide, which is also a solid at room temperature and pressure, this might also react with, yes, this also reacts with hydrochloric acid. And in this case, no gas is produced, but there could be only one observation, and that would be the size of the solid. The size of the solid should reduce because it is reacting with the acid, producing salt and water. And ultimately, it should vanish from there. It should disappear from there when it is fully reacted with the HCl. One of the similarities here is that okay, the
Those solid reagents lose
solid,
mass.
yes, the solid reagents disappear, or you can say dissolve in the acid, while the difference between them is going to be
Bubbles.
the net
Yeah, if reference is
carbonate
observed.
physics as carbon dioxide gas is produced. So this was question number 1, carrying 16 marks. Question number 2. The strength of interaction between particles determines whether the substance is a solid, liquid, or a gas at room temperature and pressure. Part A of the question is lithium sulfide is a crystalline solid with a melting point of 938 degrees Celsius. Crystalline solid means an ionic solid. It conducts electricity when it is molten. We know every ionic compound, when it is molten, it has freely moving ions then, and it can become a good conductor of electricity. Give the formula of the particles present in lithium sulfide. So we know that
Li2SO3 होगा ना.
lithium ion hoga, one of the particles in lithium sulfide, and sulfide ion is what? Sulfur having a 2 negative charge. This is the sulfide ion. Do you get it, bete?
अच्छा.
It's different, bete. जो SO4 2 negative होता है, that is called the sulfate ion. SO3 2 negative जो है उसको हम बोलते हैं सल्फाइट ion.
Sulfide as well.
और ये
Sulfide.
S2 negative, this is called sulfide ion. Okay, a sulfur atom having a 2 negative charge is called a sulfide ion. Explain in terms of the structure of the crystalline solid why lithium sulfide has a high melting point. So we actually need to talk about the structure first of all, and then we are going to explain why the melting point is so much high for lithium sulfide. So you need to tell that lithium sulfide has a giant ionic lattice. It has what?
तो हमने ionic bonding के बारे में बात करनी है. It has a giant ionic structure and
Yes, it has a giant ionic lattice.
the electrostatic force of attraction between the two
Yes,
giants.
with strong electrostatic attractions. Between lithium ion and sulfide ions. And thus its melting point is very high because a lot of energy will be required to overcome these electrostatic attractions. Okay, part B of the question now. Carbon monoxide is a gas at room temperature and pressure. It contains a coordinate bond. Coordinate bond can also be called what? A dative covalent bond. Explain what is meant by the coordinate bond or dative bond. So what is it?
वही इसमें donor and acceptor होता है. जो atom है वो 2 electrons दे जाता है.
Yes, a
Covalent
covalent
bond ही होता है लेकिन
in
one
which
atom gives lone pair, another electron deficient होता है तो वो accept
yes,
करना.
both the electrons of the shared pair are donated or given by one atom only. So that's called a dative bond or a coordinate covalent bond. You got it right as well. Okay. Draw a dot and cross diagram to show the arrangement of outer electrons in carbon monoxide. show the electrons belonging to carbon as crosses, and show the electrons belonging to the oxygen as these dots. So first of all, we need to make these two atoms. The first one is carbon. The other atom in this molecule is the oxygen atom. Now, carbon belongs to group 4, and we know that a carbon atom has 4 electrons in its valence shell. So 1, and then what? 2 here. Because we know an oxygen atom has only 6, and it can share only 2 of its valence electrons usually. So carbon भी 2 electrons use कर रहा होगा for bonding with it. Now the oxygen atom, it had 6 electrons of its own. You'll see that 2 of them will be shared here. The 2 electrons from the carbon. And where would the 2 remaining electrons be given? They will also be shared. One lone pair of electron is also shared by oxygen atom with the carbon to complete its octet. So overall, we can draw the shape like this. A carbon atom making a double covalent bond with the oxygen atom, and then oxygen sharing its lone pair, one of its lone pair with the carbon atom. Thus, the octet of both the atoms get completed. Is it understood?
ठीक है तो ये फिर इसको डेटिव बॉन्डिंग की भी एग्जांपल में कह सकते हैं क्योंकि इसमें
Yes, you can see now. देखो बेटे, carbon has how many electrons? 1, 2, 3, and 4. और oxygen हम देख रहे थे कि it has 6 electrons. It will share 2. The remaining 4 electrons are in the form of lone pairs. You can see carbon is, the octet of carbon is still not completed. So what does the oxygen atom do? It shares its lone pair of electron with the carbon, and thus a dative covalent bond is made. You know, usually a dative covalent bond is shown with the help of an arrow, where the tail of the arrow is towards the donor atom, and the head of the arrow is towards the acceptor atom. So it's an example of dative covalent bond, yes. Should we move on? Okay. Next part of the question, part C. Nitrogen is also a gas at room temperature and pressure. Neither carbon monoxide nor nitrogen is an ideal gas. State 2 assumptions that are made about the behavior of the particles in an ideal gas. So there could be
there is no force of attraction between them.
Okay, so there are no attractive forces between gas molecules, and
इलास्टिक कोलिजन होते हैं
yes,
वॉल्यूम नेग्लिजिबल होता है ये भी लिखते हैं
yes, volume भी negligible होता है, and the collisions between gas particles are perfectly elastic. Or if you write जो आपने भी बात की, what was that?
मैंने यही कहा था कि वॉल्यूम नेग्लिजिबल
Yes, the size of the molecules and the actual volume of gas molecules is negligible. Then its total volume. Okay, explain why nitrogen does not behave as an ideal gas at very high pressure.
हाई प्रेशर पर पार्टिकल्स करीब आ जाएंगे तो इंटरमोलिकुलर फोर्स बन जाएगी तो फिर वो आइडियल गैस बेसिस से डिविएट करेगा
Yes, जब आइडियल जब बहुत ज़्यादा हाई प्रेशर हम exert on the gases, then the gas molecules will come in very close vicinity to one another. And when the particles come very close together, some attractive forces, intermolecular forces like van der Waals forces should be present. So we can say that a, the gas molecules come closer at very high pressure, and the attractive forces or the intermolecular forces become significant, and the actual volume of the gas is no more negligible than its total volume. Okay, complete the table by naming all the types of intermolecular forces, van der Waals.
ये जो आपने बात लिखी है एक्चुअल वॉल्यूम इज नो मोर नेग्लिजिबल देन इट्स टोटल वॉल्यूम, ये मतलब हाई प्रेशर पर आके होता है.
Okay, let me explain it to you as well. देखो बेटे, we know that gases will behave ideally at low pressure, है ना? Because at low pressure they are far away from one another, and since they are far away from one another, so obviously there is no attractive force. So they are following the assumptions of the kinetic molecular theory or ideal gas, and it is behaving ideally at the moment. Furthermore, what do we mean by the actual volume? Dekho, if all these gas molecules are squeezed together, they all will occupy just a very, very small volume like this. Now, this is called the actual volume of the gas. And this whole volume that has been occupied by this gas is called its total volume. So suppose if the total volume is 100 decimeter cube, the actual volume that will be occupied by all these gas molecules in a highly compressed state, suppose it is just 0.01 dm cube. Now this quantity 0.01 is negligible as compared to 100. Hannah? This was what was said by the postulates regarding the ideal gases. Their actual volumes are negligible as compared to the total volume occupied by them. But now, if we subject the same gas to a very high pressure, you know that it is going to reduce the volume of the gas a lot, since they have a lot of vacant spaces between them. And now the gas molecules have come very closer together. Since they are in a very close vicinity to one another, the number of the gas molecule is same as was the previous one. Since they are in very close vicinity to one another, therefore some attractive forces or intermolecular forces become operational now, and they will exist now. So the gas is not behaving as ideal because it is not following that postulate of the kinetic molecular theory for ideal gases. Kinetic molecular theory में क्या कहते हैं कि ideal gas is the one which have no attractive forces, but here in this condition you can see some attractive forces developed here, so it is deviating from the ideal behavior here. Furthermore, take a look at the same volume here. This is the actual volume. Suppose it's still what 0.01 dm cube, and the total volume is suppose how much 5 dm cube. Now you know that 0.01 was negligible as compared to 100, but 0.01 cannot be negligible as compared to 5. So you can see now the actual volume is also not negligible as compared to the total volume which is occupied at high pressure. So even the second postulate is not followed here, and that's why the gas is behaving non-ideally in this condition.
अच्छा, नहीं तो आप कह रहे हैं उस 5 dm क्यूब को नहीं मतलब इग्नोर कर सकते, ये कहना चाह रहे हैं.
हाँ मतलब वो जो एक्चुअल वॉल्यूम है उसको आप टोटल वॉल्यूम यानी 5 dm³ के मुकाबले में इग्नोर नहीं कर सकते. Okay. The third part is complete the table by naming all the types of intermolecular forces van der Waals in separate samples of nitrogen and carbon monoxide. now भाई van der Waals forces कहाँ पर present होंगी? Yes.
हमसे पूछ क्या रहे हैं कि कंप्लीट टेबल ऑल द टाइप्स ऑफ वैन डर
Yes.
वाल्स. अच्छा अच्छा अच्छा. तो उसमें जो है टेम्परेरी डबल डबल फोर्स होंगी नाइट्रोजन में.
जी instantaneous dipole, induced dipole, id forces या van der Waals forces होती है. ठीक है.
और
Since we
कार्बन
know that
मोनोऑक्साइड में
since we
परमानेंट
know that
डाइपोल
बेटे
डाइपोल.
कि नाइट्रोजन जो है molecule it's made up of two similar atoms with the two same electronegativity values and it's a non-polar molecule. So non-polar molecules have only one attractive force between them and that is van der Waals force or the instantaneous dipole induced dipole force. While carbon monoxide, what kind of a molecule is it?
पोलर. You get
It's a
different
covalent one,
electronegativity.
but it has a permanent dipole as well. Because oxygen is the second most electronegative element here with the electronegativity value of 3.5, while that of the carbon is 2.5. So there exists a difference of electronegativity, which is 1. So the more electronegative element, oxygen will tend to push the electrons or pull the electron more towards itself, and thus it will bear a partial or delta negative charge, while carbon, being less electronegative, will get a partial positive charge or a delta positive charge. So this molecule is polar. Polar molecules में कौन सी attractive force होती है भाई? They have
परमानेंट डाइपोल.
permanent dipole forces. So this is one of the force. And what is the name of the second attractive force here?
वैन डर वाल्स.
Van der Waals forces. Because we know Van
अच्छा
der
हमें
Waals
सारी मेंशन करनी है.
Van
ऑल
der
टाइप.
Waals force will be present in every type of molecules, whether it's polar or non-polar. Okay. G. Suggest why the bond in a molecule of carbon monoxide contains a dipole moment. Why does it contain a dipole moment? Since we know that oxygen is more electronegative than a carbonate. Okay, now question.
डाइपोल. जब डाइपोल मोमेंट की हम बात करते हैं तो इसका यही मतलब है ना. मतलब जैसे मैंने बुक में भी पढ़ा था कि अगर एक मॉलिक्यूल जैसे CCl3 हो गया तो वो हमसे डाइपोल मोमेंट का पूछ रहे हो, डायरेक्शंस की बात करते हैं. तो जो
डायरेक्शंस की
अगर
बात
ऊपर
होती है, we know that कि डाइपोल मोमेंट एक्चुअली क्या होता है बेटे? It's a vector quantity, है ना? अब आप देखें कि जो डाइपोल मोमेंट होती है उसकी डायरेक्शन कैसे होती है? A vector can be shown with the help of an arrow. एरो की डायरेक्शन वेक्टर की डायरेक्शन है, एरो की जो लेंथ होती है दैट इज द मैग्नीट्यूड ऑफ दैट वेक्टर. तो आप देख रहे हैं यहाँ पर इस तरह का वेक्टर बन जाएगा. दिस वेक्टर रिप्रेजेंट्स द डाइपोल मोमेंट and you see the dipole moment of this molecule is not zero. It has some value. If the dipole moment of something is not equal to zero, then it is said to be a polar molecule. But do you know carbon dioxide molecule is non-polar? And do you know the reason why? Oxygen atoms.
दोनों के मोमेंट से दूसरे कैंसिल आउट करते हैं.
Yes, you see, this is the first dipole moment from the partial positive to the partial negative end. This is the second dipole moment here in this molecule, again directed from the partial positive to the partial negative. Now, overall dipole moment for this whole molecule should be the resultant vector of both of these. Now, if you add both of these vectors, you know that the second vector should start from the head of the first one, and it's directed like this. So you see the resultant vector that is equal to 0 over here, and thus this carbon dioxide molecule is non-polar. Any molecule for which the value of dipole moment is equal to 0, that's considered a non-polar molecule. I hope it answers your question. Question number 3 देखिएगा बेटे. A large excess of 2 bromo 2-methyl propane. So it's 2-bromo and 2-methyl propane. Structure is like this. We know that bromine is attached to this carbon atom here, which is then directly attached with 3 other atoms. Such a carbon atom is called a tertiary carbon atom, and this one here is a tertiary halogenoalkane. You should also know that tertiary halogenoalkane they follow the SN1 mechanism, which is a 2-step process. Okay. So a large excess of this 2-bromo 2-methyl propane is added to 0.001 mole of sodium hydroxide, which contains a few drops of phenolphthalein indicator as well. A stopwatch is started as soon as the substances are mixed. The time taken for the pink color of the phenolphthalein in alkali to disappear is recorded. The experiment is repeated at different temperatures, keeping all concentrations and volumes of the reagents constant. Explain what is meant by the term rate of the reaction. Yes.
यही होता है ना, change in amount of reactants or products per second.
Yes. So it is the change in concentration or mass, or you can simply say the amount of a reactant or a product with time. That is for the rate of the reaction. G, part B of the question. The graph shows the energy distribution of the molecules in a sample of 2-bromo 2-methyl propane at 25 degrees Celsius. EA represents the activation energy for the reaction. Now we have to label a few parts in this. Part 1 of the question is label the graph to show the proportion of 2-bromo 2-methyl propane molecules which have sufficient energy to react. So yes, how would it be shown?
Activation energy से ऊपर वाली एरिया को शेड कर दो.
ये वाला जो एरिया है, this shaded area represents the number of 2-bromo 2-methyl propane molecules which are able to cross the activation energy barrier and are producing the product here. So this is the area. We have to label this one. This area is showing 2-bromo 2-methyl propane molecules with sufficient energy to react. Okay, part 2 of the question is use the same axis to sketch the distribution of energies of molecules in a sample of 2-bromo 2-methyl propane at 50 degrees Celsius. Now, I guess आपको याद होगा कि this one has been made at 25 degrees Celsius. So when the temperature increases, yes, the rate of the reaction increases, और साथ में ऐसे molecules जो हैं उनकी भी quantity का number increase हो जाता है.
वो right side पर और उसकी जो peak के नीचे हो जाती है.
Yes, so the peak should be a little lower and towards its right hand side, and the shaded area should increase as well. ठीक है?
अच्छा, अभी कहते हैं state the effect of an increase in temperature.
So this one is at 50 degrees Celsius. Yes. Okay, state the effect of an increase in temperature on the activation energy for the reaction. Now you know that
the number of molecules with activation energy.
No. There is no change in activation energy even if we increase the temperature.
In number of molecules ज़्यादा हो जाते हैं ना?
Yes, number of molecules तो ज़्यादा हो जाते हैं, लेकिन क्या activation energy barrier जो है वो भी change होता है? The answer is no. एक्टिवेशन एनर्जी बैरियर सिर्फ एक ही चीज में चेंज हो सकता है, और वो क्या है? व्हेन वी आर यूजिंग अ कैटलिस्ट। ठीक है, जब हम कैटलिस्ट यूज करेंगे तो फिर ऑटोमेटिकली एक्टिवेशन एनर्जी कम हो जाएगी। Then this will be the activation energy in the presence of the catalyst, and you automatically will see that the shaded area will increase. ठीक है,
अच्छा, ये इफेक्ट ऑन एक्टिवेशन एनर्जी पूछा। एक्टिवेशन एनर्जी को तो नहीं कुछ हो रहा, बस वो
एक्टिवेशन एनर्जी को कुछ
मॉलिक्यूल्स।
नहीं हो रहा। एक्टिवेशन एनर्जी अगर यहाँ पे कैटलिस्ट का वर्ड आ जाता तो फिर हम कहते कि डिक्रीज हो रही है। So anyways, no change at the moment. Draw the mechanism to show the reaction of 2-bromo-2-methyl propane with hydroxide ions. Show the intermediate formed in this reaction. Include all charges, partial charges, lone pairs, and curly arrows as well. Abhi, so what is the first step? I told you it's a tertiary halogenoalkane. Tertiary halogenoalkane follow SN1 mechanism, which is a two-step process. और first step के अंदर क्या हो रहा होता है? Yes, this carbon atom here should be partial positively charged. Bromine atom being more electronegative should be partial negatively charged. So the first step in this process is the heterolytic bond fission. And what happens? It results in the formation of a tertiary carbocation. Okay. And then in the second step, it will combine with the hydroxide ion. So साथ में bromide ion भी obviously will be released. Okay, the second step should be the first step. In the second step, the tertiary carbocation will be attacked by the nucleophile, which is the hydroxide ion. और hydroxide ion जो है उसको आप जब represent करेंगे, then you need to put a lone pair on the oxygen atom as well. This is the nucleophile, attacking nucleophile, and it will attack this carbocation, resulting in the formation of the nucleophilic substitution product of this compound. Go here. G. Is it understood now? Yes, bete.
जी जी समझ आ गया।
Okay. Name the mechanism for this reaction. What is it? Nucleophilic substitution reaction. Nucleophilic substitution, or you can also say it's SN1 mechanism. Nucleophilic substitution, unimolecular. Next is the part D. The original experiment is repeated at 25 degrees Celsius with 2-chloro-2-methyl propane. Instead of 2-bromo, now it's 2-chloro. All other variables remain constant. Predict the effect of using 2-chloro-2-methyl propane compared to 2-bromo-2-methyl propane and the time taken for the pink color to disappear. And explain your answer as well. Yes. If we use this 2-chloro-2-methyl propane instead of 2-bromo-2-methyl propane, what would be the effect on the rate of the reaction, or what would be the effect on the time taken for the pink color in the hydroxide ions to disappear? Ji bete, can you guess it? Dekhiye bete, what's happening here? Okay, when you are discussing the 2-methyl and 2-bromo one, तो उसमें कौन सा बॉन्ड ब्रेक हो रहा था? Carbon to bromine bond was being broken down. And now, when we are using a chloroalkane, तो फिर उस केस में क्या हो जाएगा? Now the carbon to chlorine bond needs to be broken down. Okay, if you can take a look at the data booklet, you have those bond energies data with you as well. and bond energy data के अंदर take a look at the bond energies. Do you have the data booklet with you?
जी है।
Give it. Carbon to bromine bond. Its energy is 280 kilojoules per mole.
और कार्बन टू क्लोराइड 340।
Carbon to chlorine is a stronger bond. It's 340 kilojoules per mole. So what should happen? This reaction with the chlorine, that should be a slower one. It should take more time actually for the pink color to disappear. Okay?
अच्छा तो
So
पिंक कलर इसका है। अच्छा
pink
और
color
अगर
यार
वो
phenolphthalein का था in the alkali, ये वाला जो हाइड्रोक्साइड आया, ठीक है? The phenolphthalein was put into it, और phenolphthalein का कलर alkalis के अंदर होता है pink. So when it reacts with that compound halogenoalkane, तो alkali finish होता जाएगा and its pink color should disappear then. So what should be the effect? Okay, the reaction will become slower as the carbon to chlorine bond is stronger than carbon to bromine bond. Do you get it now?
तो इस मॉलिक्यूल का कलर पिंक था और क्योंकि ज्यादा उसको बॉन्ड एनर्जी ज्यादा टाइम लगेगा उसको ब्रेक करने में और फिर नया फॉर्म करने में पिंक
देखो
बॉन्ड
बेटे,
डिसअपियर।
please understand it now. We got this aqueous potassium or sodium hydroxide, ठीक है? और उसके अंदर phenolphthalein के कुछ drops put किए गए हैं. Phenolphthalein is when put into an alkali, it turns pink. ठीक है? Now when we add that halogenoalkane from the outside, it reacts with the hydroxide ions. So the concentration of the hydroxide ion should start to decrease in this reaction. And as soon as the concentration of hydroxide ion decreases, this pink color should fade away as well. Because the solution is no more alkaline, therefore this pink color of the phenolphthalein should disappear. अब आपको समझ आ रही है?
तो पीआर वाले में जल्दी डिसअपियर होगा क्योंकि वो उसका बॉन्ड जल्दी ब्रेक हो जाएगा।
Yes, because that is more reactive than the chloroalkanes. Okay, question number 4. The table shows the structural formula of 4 compounds A, B, C, and D with molecular formula C4H8. Complete the table by giving the systematic name of A, B, C, and D. So what should be the name of the first compound? It should be very easy. It's called, yes, but1-ene. This one here, this one should be called but2-ene, but which type of it? It's a cis but2-ene. Since you see same group of atoms on either side of the carbon to carbon double bond, this is a cis representation of this butene molecule. This one here, this should be called what? The trans but2-ene. Now, what about this one? The structure can be represented like this: CH2 double bond C and CH3 whole 2. So what is it called? It's 2-methyl, or simply you can say methyl propene. See, this is the longest chain containing the both carbon atoms of the functional group. This is carbon number 1, 2, 3. So this for sure के branch है वो carbon number 2 पे ही हो सकती है if the chain contains only 3 atoms. That's why if you even do not write down this 2 in the name, still your answer should be considered as correct. G, explain what is meant by the stereo isomerism. Yes. What is it? It's a phenomenon. It's a natural process where
अच्छा वो तो वही है जो सिस्टर्न्स आइसोमेरिज्म से
yes,
बात
cis trans भी हो सकता है, ऑप्टिकल भी तो हो सकता है ना, chiral carbon वाला. So a phenomenon where two or more compounds have same structural formula. Molecular formula तो same होता ही होता है, structural formula भी same होता है. And same types of atoms attached to each other, but with different arrangement in space. Okay, let's move to the next part of the question. W is an alkene with the formula C4H8. It reacts with HBr to form two possible carbocations. This carbocation and this carbocation. Identify W as compound A, B, C, or D. A, B, C, or D. They were there in the in this question, right there in the beginning, when we were asked to name these compounds. All of these compounds have the formula C4H8. So there are four possibilities here for this compound W. हाँ भाई, क्या होना चाहिए? What should it be? Now, when HBr is added, which law is followed or which rule is followed? When we add an HBr molecule to an alkene, Markovnikov's rule is followed. ठीक है? Do you know about it?
ठीक है
Yes.
जी
Zain, are you there, बेटा?
ये इधर ही
Markovnikov's rule का पता है आपको?
जी पता है
ठीक है. अब आप देखें बेटे, मार्कोनिकॉफ रूल जो है वो जो कार्बन एटम्स हैं, if they have the same number of hydrogen atoms attached to them, then it's called a symmetrical alkene. This is a symmetrical alkene. Even the trans-butene, that's also a symmetrical alkene. And if the number of hydrogen atoms attached to the carbon atoms of the double bond are different, like here, then that's called an unsymmetrical alkene. और unsymmetrical alkene के अंदर जब HBr की addition होती है तो the Markovnikov's rule is followed. What does the Markovnikov rule says? The hydrogen atom of HBr should attach to that carbon atom of the double bond which already has more hydrogen atoms. तो दो पहला product क्या बन जाएगा भाई? If hydrogen atom gets attached to the first carbon atom of the double bond, it will become CH3 and the bromine atom should attach here. And if anti-Markovnikov's rule is followed, like if the hydrogen atom adds on to this carbon which has lesser number of hydrogen atoms, so it will become CH2 and then CH2Br. So in this way, one bromobutane is made. Obviously, the one that is made by using the Markovnikov's rule, that is the major product of the reaction. While the other one, which is not according to the Markovnikov's rule, that's the minor product of the reaction. So what should it be? Yes, should be the compound that was labeled as A in that table because it will produce two different carbocations and two different halogenalkanes. One will be one bromobutane and there are chances for two bromobutane as well. Now we draw the skeletal formula of the major organic product formed when HBr reacts with W. तो skeletal formula आपने represent करना है भाई, where the carbon atoms and the hydrogen atoms are not shown. ठीक है? So it can be like there are 4 carbon atoms there, 1, 2, 3, and 4. And the major product was 2-bromobutane. So put a bromine atom here. This is the skeletal formula for 2-bromobutane, the major product of that reaction. Okay? And explain why is this this is the major product. Nambi, why is this the major product? As the carbocation produced here is a secondary carbocation, which is more stable and less electron deficient than a primary carbocation. Due to the inductive effect of 2 alkyl groups. जी बेटा, इस स्टेटमेंट की किस हद तक आपको समझ आई है?
काफी कम समझ रही है।
ओके, टेक अ लुक। मैं एक्सप्लेन कर देता हूँ बेटे इसको। The compound with which we are starting is the but1ene CH3 CH2 CH double bond CH2, और जो मैकेनिज्म होता है इलेक्ट्रोफिलिक एडिशन का, that is this HBr. It's a polar molecule. So what happens? The bond attacks here, और सपोज कर लो कि मार्कोनिकॉफ रूल हम फॉलो कर रहे हैं, तो what will happen? CH3 CH2 CH single bond CH3. Hydrogen atom has added onto that carbon atom of a double bond which already has more hydrogen atoms, and this carbon should get a positive charge. Okay, so it's what? A secondary carbocation, because this carbon atom with a positive charge is attached with 2 alkyl groups here, and bromide ion should be made. Then this bromide ion combines with a secondary carbocation, and then that makes it 2-bromobutane. अब देखिए बेटे, this carbon atom with a positive charge, it has got 2 alkyl groups attached to it. एक ये ethyl group है, on the other side this methyl group. Alkyl groups जो हैं, what kind of a nature do they have? They have electron donating nature. They have electron donating nature. So both of these alkyl groups, they will be donating their electron density towards this carbon atom which is deficient in electrons, shown by the positive charge on it. और इससे फिर ये क्या होगा कि इसकी जो deficiency of electron है वो काफी हद तक cover हो जाएगी, and it will not remain too much positive as it is supposed to be. और जितना less electron deficient होगा ये, उतना ही ज़्यादा stable होगा. But with the other possibility, जो anti-Markovnikov rule है, in that one, a primary carbocation is made. See here, we are now attaching the hydrogen atom to that carbon atom of the double bond, which already has more, which has lesser number of hydrogen atoms. So it will be added to this carbon now, and now this carbon on the end, this will become a carbocation. Along with that, bromide ion is formed, and this bromide ion attacks it, and it results in the formation of 1-bromobutane. Okay. So take a look at this carbocation here. It has a charge a positive charge, it is electron deficient. And what is attached to it? Just one alkyl group. And ये one alkyl group इसको अपनी electron density donate करेगा. This is called inductive effect. So उससे क्या हो जाएगा कि कुछ हद तक जो है वो इसकी electron deficiency खत्म हो जाएगी, but not too much. And it will still remain quite positively charged. ठीक है? Which you can see with the size of this ion as well as compared to I have drawn over there. So it is, less stable because it is still quite electron deficient. While this carbon atom is more stable, this carbocation is more stable because it is less electron deficient because of the inductive effect of the two alkyl groups that are attached to it. Do you get it, son? Zan?
जी ठीक है, ऊपर वाला मोर स्टेबल है क्योंकि लेस इलेक्ट्रॉन डिस्ट्रीब्यूशन
हाँ, बिकॉज वहाँ पे टू एल्काइल ग्रुप्स हैं, वो अपने इलेक्ट्रॉन डेंसिटी डोनेट कर रहे हैं और डबल इंडक्टिव इफेक्ट है, तो इलेक्ट्रॉन जो है ना वो इतना डेफिशिएंट नहीं रहेगा, ये कार्बन एटम इतना इलेक्ट्रॉन डेफिशिएंट नहीं रहेगा एंड इट विल बिकम क्वाइट स्टेबल. लेकिन ये वाला इलेक्ट्रॉन डेफिशिएंट काफी हद तक रहेगा बिकॉज ओनली वन एल्काइल ग्रुप इज donating its electron density towards it. So this was the reason there. Okay, let's take a look at the next one. A sample of propane 1-ol reacts with concentrated sulfuric acid to form propene. Identify the role of concentrated sulfuric acid. So sulfuric acid is behaving as a dehydrating agent. It removes water molecule from propane 1-ol like this: CH3, CH2, CH2OH. So in the presence of concentrated sulfuric acid and heat, OH group gets removed from this carbon and a hydrogen atom will get removed from here. So water molecule is eliminated and a double bond gets formed between these two carbon atoms. So propene is produced. Removal of the water is dehydration and concentrated sulfuric acid is the dehydrating agent. The next part of the question is alcohol Y reacts completely when warmed with acidified dichromate 6 ions to form Z. Z is distilled from the reaction mixture as soon as it is made. अब देखें जो जो फौरन ही डिस्टिल कर रहे होते हैं, that is what? An aldehyde. And when are aldehydes produced? When a primary alcohol is oxidized. So when a primary alcohol is oxidized, it converts into an aldehyde, and as soon as aldehyde is made, it is distilled from the reaction mixture, and it is not allowed to convert into a carboxylic acid because we know aldehydes can very quickly oxidize to carboxylic acids. So Tollens reagent is added to the sample of the Z and warmed. A silver mirror forms. Name the type of reaction that occurs when Y reacts to form Z. We call it what? Oxidation reaction. Now we identify with a tick the functional group present in Z. Functional group present in Z is an aldehyde, and there is no ketone and carboxylic acid. Just a second, please. Give it a last question from this paper. S is a secondary alcohol with the molecular formula C4H10O. Draw the displayed formula of S. Now we have to make a secondary alcohol, the OH group, that should be attached. Displayed formula कौन सा होता है भाई? Where every type of bond and every atom is shown. And one of the mistakes that is usually made by the students here is that they do not separate the oxygen and hydrogen atom. They just write it together. So you have CH3, then CH, then there is an OH. This bond should be represented. Otherwise, you'll not get a mark for this question. Then a CH2 and a CH3. You see the carbon atom that is attached with the OH group is further directly attached with two other carbon atoms, making it a secondary carbon, and this is a secondary alcohol. Now, S is converted into B in a three-step reaction sequence. G. This is the alcohol, and alcohol has been converted into bromine. तो phosphorus trihalides वगैरह को हम use कर सकते हैं, and OH group gets replaced by the bromine atom, making a halogenoalkane. In step 2, the halogenoalkane, the bromine atom has been replaced by CN group, the cyanide group, making it nitrile here. And फिर dilute acid के साथ हम इसको treat कर रहे हैं. We know कि dilute acid के साथ जब हम इसको treat करेंगे, what should be the product? But let's take a look at the question first of all. In step 1, the secondary alcohol reacts with PBr3 to produce T, which has molecular formula C4H9Br. Give the systematic name of T. हाँ भाई, ये OH है. It was what? 2 butane 2-ol, and OH group gets replaced by the bromine, so it will become what? 2-bromobutane. Name the type of reaction that occurs in step 1. So what do we call this type of reaction? The OH group was substituted by the bromine atom, so this should be called a substitution reaction. State the reagents and conditions required for step 2. अब देखिए halogenoalkanes का reaction है with ethanolic potassium cyanide or sodium cyanide. So the reagent is ethanolic potassium cyanide or sodium cyanide, and the second thing that is done is heat under reflux. Okay, then step 3 involves heating C4H9CN with dilute acid to form V. Complete the equation for this. जी, cyanides को जब treat करते हैं with dilute acid in the presence of water, you can see this is called what? Acid hydrolysis of nitriles. Acid hydrolysis of nitriles is actually a method to produce carboxylic acids. So a carboxylic acid should be made. Okay, so C4H9CN combining with HCl and water, you should produce C4H9. The nitrile groups converts into the carboxylic acid. In order to balance the chemical equation, take a look at the number of hydrogen atoms, 9 and 110. I think we need to put 2 here. And along with that, ammonium ion is also generated during the reaction. G, is it understood?
ठीक है,
Yes, Zen.
ठीक है, सही.
G, an unlabeled sample contains either S, T, or U. So it contains either S, T, or U. S was a secondary alcohol, T was a halogenoalkane, a secondary halogenoalkane, and U was a nitrile. The sample produces the infrared spectrum as shown, as you can see. Explain how this spectrum confirms that the unknown sample contains U, and U was a nitrile. So let us take a look at the nitrile group. You have the data booklet. You can actually refer back to the infrared spectrum data given table, which gives you the values for the wave numbers regarding the infrared spectrum. Cyanide ion को हमने वहाँ से identify करना है. Usually when identifying such structures, ignore this first part up to 1500 per centimeter, and then take a look at the peaks that follow this. I'm sharing with you an copy of the data booklet where you can see the wave numbers that are associated with the different functional groups. We saw that in that compound, it was cyanidine, nitriles, in fact, not cyanidine, it was the nitrile group. And we see what? A weak peak between 2200 to 2250. So it's 2200 to 2250. It's this one. And this represents that the compound is a nitrile and it contains a nitrile group. This is what you need to write there in the answer. So this is it, beta. First paper has been done. I hope you understood it. And I'll stop sharing.